Hey, here we go with ready to go on module quiz, all about integers, scientific notation, and such. And so the first one is wow, it's 3 to the negative fourth power. Let me zoom in on here a little bit. 3 to the negative fourth power. Yikes, that's not 3 times negative 4. That is far from it. Now, let me tell you real quick. If I have 3 to the fourth power, that is 3 times 3 times 3 times 3. And, or actually, let me back up just a little bit. Let me erase this here. And I think of it like this, actually. 1 times 3 times 3 times 3 times 3. So that 4 is telling you 1, 2, 3, 4 threes. 1 time and all that stuff. And why is that 1 times? Because you can. I say at this point, because you can. It doesn't change anything. And all of this, let's see. I know that 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So this whole thing is equal to 81. Now, I tell you this because 3 to the negative fourth power ends up being 1 divided by 3, divided by 3, divided by 3, divided by 3. And so this also could be written as 1 over, because it's 1 divided by, right? Or that part right there is 1 divided by. And then we could just say that's, we could invert all this and say 1 over 3 times 3 times 3 times 3, which is 1 over 81. So you see, 3 to the fourth is, oh goodness gracious, you gotta be kidding me. 3 to the fourth is equal to 81, but 3 to the negative fourth is equal to 1 over 81. What do you think about that? So we have that as our answer right there. Anything to the 0 power is 1. I don't care what you think. It is going to be 1 for sure, for sure. And I have that right there. And this one, 8 to the third. Well, what we could do is we could have 8 to the third is, I know, it's 8 to the third is equal to 1 times 8 times 8 times 8. But you know what? I'm not going to get all fancy on this right now. I'm going to erase this because I did a terrible job of writing this. But I'm not going to write the 1 times right now. It's not going to serve me right now. So I'm just going to go with 8 times 8 times 8. Okay, and then 8 to the 7th. 8 to the 7th is 1, 2, 3, 4, 5, 6, 7, and everything's being multiplied. But everything's being multiplied. So how many 8s are being multiplied? 10 of them are. So it's 8 to the 10th. It's 8 to the 10th. And you just, obviously, yeah, you just add your exponents, 3 and 7. Add them up. So when you're multiplying powers, you add the exponents. And so when you're dividing the powers, you subtract the exponents, and 6 minus 2 is 4. But if you want to see why it's 12 to the fourth, well, let me show you first. That's 12 to the fourth. And I'd like to show you why. That's 12 times 12 times 12. That's 3 of them. 4, 5, 6 over. Oh, that's so bad. I'm going to have to write it with this. Oops. Getting there. There we go. Nice and straight. And over 12 times 12, because that's 12 to the second, and then these will cancel, and there is your 12 to the fourth. 1, 2, 3, 4. That's why. 12 to the third to the fifth. Okay, you know what? I'm just try a pencil version of this. So 10 to the third is 10. 10. Oh, come on. Are you serious? 10 times 10 times 10. That's not dark enough at all. I'm not going with pencil version anymore. Oh, let's see. Over, let's see if this will do it. Oh, no. That's 10 to the third. That's too light. I'm not down with that at all. Okay, 10 to the third, and then to the fifth means I'm gonna need some room for this here. To the fifth means I have to do this 5 times. 10 times 10 times 10. That's doing it 2 times. 10 times 10 times 10. That's doing it 3 times. 10 times 10 times 10. 4 times. And make it smaller. 10 times 10 times 10. There's 5 times. So the question is, how many 10s do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And yeah, the quick way is to multiply 3 times 5, 15. 10 to the 15th power. Oops, I don't have to do that because it should be right there. 10 to the 15th power. Okay, what else we got? Scientific notation. So convert each number into scientific notation or standard notation. Okay, so scientific notation, that's just going to be, well, it's going to be this. 2 times 10 to the third, because you have to put the decimal here because it makes it a number between 1 and 10, and you have to move the decimal 1, 2, 3 times to the right. Let's try that again. You have to move it 1, 2, 3 times to the right, so that's what the 3 is for. The 3 is not how many zeros you have. In this case, it happens to be that, but it's how many times you have to move the decimal. For instance, this one. This is saying move the decimal 9 times to the right. So I'm going to move it 1, 2, 3, 4, and then I have to move it 5 more times. So it's going to be 5 zeros after this. Watch this. It's going to be 5 zeros afterwards. So here's 1, 2, 3, 4, 5. 5 zeros because I had to move it 9 times to the right, and that's 1, 2, 3, 4, 5. Oh, how about this? At 4, 5, 6, 7, 8, 9. See, so there's zeros that go in here, and so that's what those 5 zeros are right there. Next, you've got to put this in scientific notation, so we have to put a decimal right there, and you have to move it 1, 2, 3, 4, 5, 6, 7 times. So that's the exponent is 7, and you got it right there, 9.10075. Okay, there are those, and then 7 times to the right. You got to move it. This one, you have to move the decimal 4 times to the right, so it's going to be 4 zeros, 2 zeros after the 4. Where is that thing? There, 400. Now we have negative powers of 10. So this, if I place the decimal right there, I have to move it 2 times to the left, so it's a negative 2. So so it's right here. 2 times 10 to the negative 2, because that negative 2 right there tells you move the decimal to the left 2 times to make that number. 5 times to the left means it's going to be this. 1, 2, 3, 4, 5 times to the left, and you're going to fill this in with zeros, so you're going to be 4 zeros, and then 8, 9 on that, and that is what this is here. So 1, 2, 3, 4 zeros, but the decimal actually belongs there, and there you go. And we have this here. I have the decimal would go right there, because that's the only way you're going to create a number between 1 and 10. So it's going to be 7.01 times 10 to the negative 1, 2, 3, 4. I have to move it 4 times to the left, so it's going to be a negative 4 on the exponent right here. And our last one, this is going to move the decimal 2 times to the left. Right there, 2 times because of that. So it's going to be 0.0441. 0.441. Okay. And we got all these others here. Okay, so we have to perform the operation. I think that what I'd like to do is set this up over here. Come on over here. And I'd like to blow this up a bit. And let's make this bigger. So, okay. So we're gonna do 7 minus 5.3. That's the first thing. So 7 minus 5.3, that's 0.7, what, 1.7? And then times 10, and times 10 to the 6, because that 6 is the same exponent on both of those. So that's what I think it is. Let's see if I'm right. So 1.7 times 10 to the 6. Great. Okay. So we have this one, 3.3. Okay, we're going to add these. So this is going to take a little bit more work here. Oops. So let's go here. Take it over here. And let's move this to the top. So the exponents need to be the same. So let's say if I want to make them the same, maybe I'll make that to the 5th. I guess I'll make that to the 5th power. So if I make that to the 5th power, I gotta think this through here. 3.4 times 10 to the 4th is equal to 3, 4, and I have to move it 1, 2, 3, 4. So that's equal to 3, 4, 0, 0, 0. Now I need to make this times 10 to the 5th. So that would be, well, if I add a 0, I haven't changed the number, so I believe that would be 0.34 times 10, oops, 10 to the 5th. That should be the same thing. Yeah, I could have done that a lot easier. Okay, anyway, so what we have is 0.34 times 10 to the 5th plus 7.1 times 10 to the 5th. Now I'm ready to add 0.34. 0.34 plus 7.1, that's 447. So that's 7.44 times 10 to the 5th power. Let's see how I did. We got this, 10 to the 5th. Perfect. Okay, so I got this one here, and I'm going to move this over here and move that bigger and move this up. Okay, so I'm going to, well, everything's being multiplied. So I would start with 2 times 5.4, which is 10.8. And so let's see. So it's 10.8. And then we have 10 to the 4th times 10 to the 6th, which is 10 to the 10th, because you add those exponents. Now we put this all together, we would have 10.8 times 10 to the 10th. But we can't do this because that is bigger than 10. So that decimal needs to go over here. Now if I move the decimal over here, this exponent has to increase by 1, because remember, this 10 says I have to move it 10 spaces all the way to the right. So if I have it here, I now have to move it 11 spaces to the right for it to be the same number. So this is equal to 1.08, all I did was move the decimal, times 10 to the 11th now. And let's see how I did. 1.8 times 10 to the 11th. Nailed it. Okay. And now we have this here. I'm going to copy this and bring it over so I have some room to work with. Oops. Right here. And I think I'm going to erase this other stuff. So get rid of any of that any resemblance of another problem. And that's going to go bigger. Okay, that's crooked now. Okay, good. So we have, I'm going to separate this. It's going to be 7.86 divided by 3, and then times, and then 10 to the 9th over 10 to the 4th. Now this other part is going to be 10 to the 5th. That's easy. You just subtract the exponents. And 7.86, all you do is 7.86 divided by 3 is 2.62. So 2.62 times 10 to the 5th, that's in scientific notation because that is a number between 1 and 10, and that should be the answer right there. So I'll bring this away here and do that times 10 to the 5th. Okay. Now we have this other. Okay, so Neptune's average distance from the sun is 4.503 times 10 to the 9th. Mercury's average distance sun is 5.791 times 10 to the 7th. How many times farther from the Neptune is how much farther from the sun is Neptune than Mercury? Write your answer in scientific notation. So it would be this Neptune, this divided by this. Or how much farther? No, not how many times. Yeah, how many times? Okay, so it would be this divided by this. Let's do that. I'll have to do it right over here. I'll do it in blue. 4.503 times 10 to the 9th over 5.791 times 10 to the 7th. Well, I think that what I would have to do, I think I'm going to do something a little sneaky here because I realize I'm going to run into a problem if I do this divided by this. It's going to end up with a number less than 1. Well, what I could do, no, I could do that. So I have 4.503 divided by 5.791. It's 0.7775. 777, actually 6. Okay, times 10 to the 2nd power. Now, if I have this, I need to move the decimal one time over here to make a number between 1 and 10, because right now it's 0.7 smaller than 1. But if I move it this way, then this has to decrease by 1. Because, yeah, that would be, so 2 times here means we're moving it twice, and if I move it here, then I only have to move it once now to put it in position. So that would be 7.776 times 10 to the 1st. And that should be my answer in scientific notation. And I have, yes, exactly. Okay, I will erase this. And how is scientific notation used in the real world? Here is an example. Right here. Well, with super large numbers, such as distances in space, and very small numbers, such as sizes of atomic particles, can be written in scientific notation. You know, you got a lot of zeros going on. So that's what you got to know with scientific notation, operations with that, and negative exponents. Hope this has been helpful. Thanks for watching.